The human appendix. The human appendix sits at the junction of your small and large intestines. For most of human history, nobody knew what it did. In our plant-eating ancestors, it was much larger, functioning as a fermentation chamber to break down tough plant fibers. Some herbivores like koalas still have massive versions that can be up to 6 feet long. But as humans evolved to eat more diverse diets, including meat, we didn't need this cellulose digesting factory anymore. Today, your appendix is about 3.5 inches long and 0.2 inches wide. That's roughly the size of your pinky finger. While some researchers think it might house beneficial gut bacteria or play a minor role in immunity, you can live perfectly fine without it. About 1 in 20 people will get appendicitis in their lifetime, where it becomes inflamed and needs emergency removal. Wisdom teeth. Wisdom teeth made perfect sense when our ancestors had larger jaws and needed extra grinding power for raw plants, nuts, and uncooked meat. Their jaws were about 30% larger than ours. But around 10,000 years ago, humans discovered cooking. Cooked food is softer and easier to chew, so we didn't need massive jaws anymore. As our brains got bigger, our jaws got smaller to make room. The problem is, our teeth didn't get the memo. Most people still develop wisdom teeth, but 85% of them need removal because there's simply no space. They grow in sideways, backwards, or get stuck under the gums, causing infections, cysts, and damage to other teeth. Some lucky people are born without them entirely. Scientists predict that within a few thousand years, wisdom teeth might disappear completely. The coccyx. At the very bottom of your spine sits the coccyx, made of 3 to 5 fused vertebrae. It's all that remains of what was once a functional tail used for balance and communication. If you look at a human embryo at 4 weeks, it actually has a tail that's about 1/6 of its total length. By week 8, it's mostly absorbed back into the body, leaving just the coccyx. Other primates lost their tails around 25 million years ago when they started spending more time upright. About 1 in 13,000 babies are still born with a vestigial tail, sometimes several inches long. These are usually removed shortly after birth. The coccyx isn't completely useless, though. It serves as an attachment point for various muscles and ligaments and helps support you when sitting. But break it, which happens more often than you'd think from falling on your butt, and you'll discover just how unnecessary yet annoyingly present it is. Body hair. Humans have the same number of hair follicles as chimpanzees, about 5 million, but our body hair is so fine it's almost invisible. Scientists call it vellus hair. The leading theory is that we lost our fur around 1.2 million years ago when we started persistence hunting, chasing prey until it collapsed from heat exhaustion. Fur would have caused us to overheat. We evolved better sweating mechanisms instead, with up to 5 million sweat glands compared to chimps who have almost none. But evolution kept some reminders. You still get goosebumps when cold or scared. A leftover reflex from when raised fur made our ancestors look bigger to predators or trapped air for warmth. The tiny muscles that cause this, called erector pili, are attached to each hair follicle. They work perfectly if you're a cat, but on a mostly hairless human, they just make you look like a plucked chicken. The palmaris longus. Put your hand palm up on a table, touch your thumb to your pinky, and slightly lift your hand. See that raised tendon in the middle of your wrist? That's your palmaris longus. Except 14% of you won't see anything, because you don't have one. This muscle helped our ancestors grip tree branches while swinging, but it's so useless now that surgeons routinely harvest it for tendon grafts. Having it or not having it makes zero difference to your grip strength. What's fascinating is the variation. Some people have it in one arm but not the other. Male nipples. Male nipples exist because nipples form in the womb before sex hormones kick in. For the first 6 to 7 weeks, all embryos develop identically, following a basic female template. Only later, if the embryo has a Y chromosome, testosterone flooding begins and male characteristics develop. By then, the nipples are already there. Evolution could have programmed male nipples to disappear, but there was no survival disadvantage to keeping them, so it didn't bother. Interestingly, men can actually lactate under certain hormonal conditions, proving the basic equipment is all there, just normally switched off. The vomeronasal organ. In your nasal cavity, there's a tiny pit called the vomeronasal organ, or Jacobson's organ. In other mammals, this is a functioning chemical detector for pheromones, those invisible signals that communicate things like territory, aggression, or sexual availability. Snakes and cats have highly developed versions. When a cat does that weird face with its mouth open, it's using its vomeronasal organ. In human fetuses, this organ is clearly visible, but in adults, it's either microscopic or completely absent. The genes that would make it functional are mutated and switched off. Some researchers argue humans might still produce and detect pheromones through other means, pointing to studies about menstrual synchronization or babies recognizing their mother's scent. But our conscious pheromone detection system? Evolution deleted that feature millions of years ago when vision became our primary sense. The Darwin's point. Look carefully at the outer edge of your ear. About 1 in 10 people have a small pointed projection on the upper part called Darwin's point, or Darwin's tubercle. This is the last remnant of the pointed ears our ancestors used to swivel toward sounds. Many mammals can still rotate their ears independently. Humans technically have the muscles for this, 3 of them actually, but they're so weak that only a few people can wiggle their ears at all, and nobody can truly orient them toward sounds. The pointed shape helped funnel sound waves, but as our ancestors developed better communication and social cooperation, precise sound localization became less critical for survival. The point gradually smoothed out, though genetics occasionally still expresses this ancient feature. The plica semilunaris. Look at the inner corner of your eye next to your nose. That small pink fold of tissue is your plica semilunaris, the remnant of a third eyelid. Reptiles, birds, and some mammals have a fully functional version called a nictitating membrane that sweeps horizontally across the eye for protection and moisture while maintaining visibility. Sharks use theirs when attacking. Camels use theirs in sandstorms. Your ancestors had one too, but as primates evolved better regular eyelids and tear systems, the third one became redundant. Now it's just a tiny fold that does nothing except occasionally collect eye gunk. Sinuses. Your skull contains 4 pairs of air-filled cavities called sinuses. They're lined with mucous membranes that are perfect breeding grounds for bacteria. They drain poorly because their openings are oddly positioned. Anyone who's had a sinus infection knows they serve mainly to create pressure, pain, and produce shocking amounts of mucus. The leading theory for why we have them is weight reduction. As human brains tripled in size over 2 million years, our skulls needed to get bigger too. But a solid bone skull that large would be too heavy for our neck muscles. Air-filled spaces made our heads lighter while maintaining structural strength. These remnants of evolution aren't flaws or mistakes. They're evidence of the endless compromises and adaptations that led to modern humans. Your body is essentially a museum of evolutionary history, carrying around exhibits from different eras. Some cause problems, like appendicitis or impacted wisdom teeth. Others are just along for the ride, like your tailbone or Darwin's point. Evolution doesn't create perfection. It creates things that are good enough to survive and reproduce. These vestigial organs are reminders that we're not the end product of evolution. We're just another transitional form, carrying the past while slowly adapting to the future. If you liked this video,